Refraction, laws of refraction, Snell's law, applications of refraction. When a beam of light encounters the interface of two media, a part of the incident ray reflected back to the media, and the rest of the ray and just travels through the second medium. So we can say that at the interface, the direction of the incident ray changes at the interface. That is depending on the refractive index of the medium. So we can say that there is a change in direction in the incident ray. So this change in direction is known as the refraction of light. Snell's studied reflection of light, and the experimental observations are termed as two laws. First law of refraction says that incident ray, reflected ray, refracted ray all lies in one plane, and second statement of laws of refraction states that sine of the angle of incidence to the ratio of sine of the angle of incidence to the ratio of sine of the refraction is a constant, and that constant is known as refractive index of second medium with respect to first medium, or we can say that it is n21. This is Snell's law of refraction. Here incident ray is shown in the figure, and that angle of incidence is denoted as I, and the angle of refraction is also denoted as I because angle of reflection is equal to angle of incidence, and angle of refraction is denoted as R because it bend towards the normal in this case. So this may be varied according to the media. So depending on the media, this angle will change. Snell's law says that sin I by sin R is equal to n to 1. This is a characteristic of the pair of media. It depends on pair of media. The value will change according to pair of media, and it depends on wavelength. Wavelength of the light depends on velocity, so it depends on wavelength. Third one, we can say that n21 refractive index independent of I or R, it independent of angle of incidence. That is the case. When we analyze the diagram, we can say that when n21 is greater than 1, we can argue that sin I by sin R, from sin I by sin R is less than I. That means angle of refraction is the less than angle of I. So refracted ray bends towards the normal. So here we can say there is a bending towards the normal, and you can say n second case is n21 is less than n1, and you can say R is greater than I, so the refracted ray bent away from the normal, and you can say that n12 is equal to n21, or you can say n12 is n1 by n2 and n21 is equal to n2 by n1. So these are the reciprocal. N12 is the reciprocal of n21. There are three applications of refraction are there. We can first say that it is apparent depth case. In apparent depth case, we can say the fish in the water tank or fish in the pond appears to be raised a little, and bottom of the water tank is also appears to be raised. So these are the examples that is meant by apparent depth. Second application is advanced sunrise and delayed sunset. Just before 2 minutes of the actual sunrise, we can see a sunrise, that is the advanced sunrise, and actual after the actual sunset, we can see a sunrise just for 2 minutes, that is called the delayed sunset. and the oval shape of the sun at sunset and sunrise is also due to the refraction of the light. So these are all the refraction of the applications of refraction of light.